Welcome back to Logical Thinking, and today we're going to talk about another logical deductive argument called the hypothetical syllogism. Don't be scared away by these big words. The hypothetical part just means we don't use this to establish the truth of a conclusion, rather we use it to link arguments together to get what could or would be true if we know the arguments are true, which we usually eventually try to argue later. And the syllogism part is just a fancy way of saying a deductive argument based on two propositions asserted or assumed to be true. So modus ponens and modus tollens, which we talked about in our last video, are examples of syllogisms. The hypothetical syllogism goes like this. Premise 1, A implies B. Premise 2, B implies C. And our conclusion, A implies C. For an example, consider the following. We'll use the example we've been using. Let A be the proposition that there are more than 5 mph winds, B be the proposition that Project 305 in Virginia is closed, and C be the proposition that I'm disappointed. In this example, premise 1 says that if there are more than 5 mph winds, then Project 305 will be closed. Premise 2 says if Project 305 is closed, then I will be disappointed. And our conclusion says that if there are more than 5 mph winds, then I will be disappointed. And as an aside, this is a true story. I once went to King's Dominion in Virginia, and Project 305 was closed due to the winds, and as a result, I was disappointed. Now, one of the important things to remember here is this implication doesn't necessarily say anything about cause and effect. I may be disappointed because the ride I want to go on is closed, not really because of the weather. However, if the ride will be closed because of the weather, I can say that I'll be disappointed if the weather is bad. I may not even be aware that the ride is closed because of the weather. However, if the weather and the ride's closure are logically connected, someone who knows the ride cannot operate in mild winds may conclude that I'll be disappointed under certain weather conditions that cause the ride's closure. So once again, this is the difference between realizing something that's causing something and realizing the logical connection between them. Now, to show that this is a valid form of argument, let's go ahead and create a truth table. We're going to need 8 rows in our truth table to capture all possibilities of A, B, and C. 2 for A, 2 for each value of B given A, so 2 times 2, and then 4 times 2, 2 for each value of C given every combination of values of A and B. So 2 times 2 times 2 is 8 rows in our final truth table. And we're going to go through each possible combination. So let's start by filling out A implies B. We know the truth table of the conditional or the material implication from our video on logical connectives. So let's go ahead and start with this. I'm just going to kind of gray out these other ones that we're not looking at. Once again, A implies B is only looking at the connection between A and B, so we can ignore C for now. Remember that A implies B is true when the antecedent, meaning A, is false. It's just vacuously true. So we're going to fill that in with true here in rows 3 and 4 and 7 and 8. When both A and B are true, when both the consequent and the antecedent are true, then A implies B is true, so we're going to fill in true there. And when the antecedent is true but the consequent is false, A implies B is false, so we can fill in false for that remaining section. Let's move on to B implies C. We're going to be looking at columns 2 and 3 of our truth table. And I'm going to gray out these other ones so we don't get confused. As before, remember that B implies C is true whenever our antecedent B is false. So we're going to put in true in each of these places. Now, B implies C is true when both B and C are true. So we'll go ahead and put true in rows 1 and 3. And lastly, when the antecedent is true but the consequent is false, we're going to put false for B implies C. And lastly, let's look at our conclusion premise. We'll go ahead and blank out B and the last 2 columns we just filled in. And once again, we'll start when the antecedent is false. We'll put true here. Then what we're going to do is look when both the antecedent and the consequent are true. Put true in there. And once again, when A implies C, remember it's false when A is true and C is false. So we're going to put a false for these 2 rows. Now let's go ahead and look at the conjunction of our 2 premises and see if the conclusion logically follows. So starting out, let's look at A implies B. This is premise 1. It is false on row 2 and looks like row 6. So let's go ahead and X these rows out. Moving on, let's look at premise 2, which says that B implies C. This also needs to be true, so we can cross out any row where it's false because of De Morgan's law. And here we go. This is row 5 and row 7. So let's go ahead and cross those out as well. And we have 4 leftover values for A implies C. However, in each of these 4 rows that are left over from taking the conjunction of premise 1 and premise 2, meaning A implies B and B implies C together, we actually have that A implies C is true in all of our remaining cases. So it is the case that premise 1 and premise 2 taken together imply the truth of C. We've exhausted all possibilities. So we can say that C does follow from premise 1 and premise 2, and thus A implies B and B implies C implies that A implies C. So we've approved this as a valid deductive form. One of the things to mention is the hypothetical syllogism is often combined with modus ponens or modus tollens to chain a bunch of different premises together. The hypothetical syllogism is like a long chain of arguments placed together such that if the premises are true, things down the line are true. So once you establish that first link, all the rest of them are true and you get to the end. So you have A implies B, B implies C, so on and so forth to get to G. You hit A, boom, they all knock down, and you get G. So back to our domino analogy, the hypothetical syllogism tells us which dominoes, like G in this example, are placed in the path of other dominoes. So we can make these super long domino chains of arguments. However, we can't arrive at any of these conclusions unless we know that one of the premises is true, or perhaps that one of the conclusions is false. This would be like modus tollens. So once again, we would need some other type of argument to establish it. One way to think about this too, the hypothetical syllogism, is like the transitive property in arithmetic, where if A equals B and B equals C, then we can conclude that A equals C. Anyway, thanks for watching and hope you found this helpful. I'll see you in the next video where we'll talk about the disjunctive syllogism and the constructive dilemma. Those are the last two deductive forms we'll be talking about.